Good afternoon, this is James Carlin, the product manager for dampers here at Pottorff, and I'm about to begin our 2015 International Building Code Section 717 presentation. As a note, Pottorff, we're a leading manufacturer of louvers, dampers, and noise control products. We're celebrating our 90th anniversary this year, and we pride ourselves on our foundation of service and quality, as well as our dedicated employees that have led to our continued success. As a note, this presentation is registered with the American Institute of Architects and Continuing Education Systems, so we will be giving out certificates of completion upon at the end of this presentation. Just make sure that you have registered with your full name and email address so you can get that presentation certificate. Starting off by giving an overview of the presentation. Basically, we'll talk a little bit about the code development process and move into some damper ratings and actuation. And then the bulk of the presentation will be going over the damper requirements by the different assembly types. Originally, there were many different code regions. Some of the big ones were IBC, BOCA, and the Southern Building Code. And because of the differences between these different code organizations and regional building codes, it was difficult for engineering firms and for fire inspectors to understand exactly what's needed. Because of that, the different code regions joined together to create the International Building Code the International Code Council in 1994, which then developed the Unified Mechanical Code and the International Building Code. The first edition of the International Building Code started in 1997 with widespread adoption in the year 2000. It goes on a 3-year adoption cycle. So the current widespread adoption code is 2015, excuse me. But the most recent version of the code is from 2018. There weren't many changes that'll affect this presentation in this section, so there's really not a whole lot of updates needed, but that code is just going into press and hasn't been adopted through widespread markets. In fact, you may see regions that still have older versions of the building code they're working to, potentially back to earlier versions as early as 2006 or potentially earlier, depending on the level of renovation or modifications that were needed to grandfather existing buildings. Basically, the adoption cycle allows anyone to propose amendments, but the proposals are then heard by code officials to keep a commercial aspect out of the code itself. They are the ones that actually determine in the end what will be added to the code finally through adoption, either through new portions of the code or amendments to the code. And the code works basically to add layered protection, which would be both passive and active, where your passive protection comes from rated walls, rated assemblies, and dampers, while your active protection comes from both sprinklers and, say, smoke control type systems, typically under 909 section of the building code, and we will talk about that later. And basically the layered protection works for fire and smoke containment. Now, there are some new things to the code. Most of these dampers that we list here have been in the code, but there have been some minor changes to the ceiling radiation dampers and the corridor dampers that I'd like to touch on for the 2015 version of the code. The ceiling radiation damper changes basically stem from part of the requirement from the Universal Mechanical Code. Now, the Universal Mechanical Code requires that air handlers or air distribution units that provide more than 2,000 CFM to shut down in an emergency, but anything less than or equal to 2,000 CFM doesn't have that requirement. Typically in, say, multifamily housing, what you would find is these smaller units that then would be going and supplying or bringing return air through a rated ceiling. The problem with that is any penetration of a rated ceiling needs to be protected by a ceiling radiation damper. But as the fan is not shut down in these, or the air handler is not shut down in these emergency situations, you then need a dynamic damper to close under that airflow. The code was silent on the requirement of having a dynamic ceiling damper. It didn't specify static versus dynamic, and where static dampers close under no airflow and dynamic dampers close under airflow. So basically all ceiling radiation dampers at that point were static dampers, even though there was this need for them. Because of that, the code adopted the verbiage to allow for a dynamic rated ceiling radiation damper. The problem with that is there is no dynamic rated ceiling radiation damper. As you can see in the top right portion of this presentation, there's the slide, there's a simulated horizontal fire test, and basically that's a fire rated floor that has traditional style fire dampers installed into it. It's a little different than a ceiling radiation or a ceiling assembly test, which that would be UL 555 versus UL 263, where it tests the entire rated floor ceiling assembly. So not just the floor, but the ceiling below it as well. Typically these are metal stud, wood stud, or wood joist type ceilings, and the entire assembly is required to be tested. In order to do that under dynamic flow, it would be very difficult to achieve the ratings in the damper. It would require significant additional cost to the damper and the overall assembly to pass that test, as these are load-bearing structures, and that will need to go through this fire rating and are combustible. So as they're deteriorating, they need to have the load of the fan, or UL feels they need to have the load of the fan and the damper at the same time. Unfortunately, there's no good way to mimic that. There's no good place to put the furnace without weakening the structure of that test floor ceiling assembly and limiting your ability to withstand that load for up to an hour. Because of that, there's no dynamic rated ceiling radiation damper currently on the market. And we, as a ceiling radiation damper manufacturer, urge engineers to put in any type of smoke detection and that shutdown that's required for air handlers above 2000 CFM on all their air handlers to make sure it is a static system, as if you're penetrating a rated ceiling, you only have static ceiling radiation dampers available for those penetrations. It's new to the code, and we're glad that the code realizes the requirement is there, but unfortunately it will be much more likely that the need for a smoke detector, some smoke detection to shut down the air handle will be used for quite some time, as many ceiling radiation damper manufacturers throughout the industry don't feel they can actually pass the testing required for these dynamic rated ceiling dampers. The only other change to the types of life safety dampers is the code adding tunnel type corridors, which I won't spend too much time on since this presentation is geared primarily to the East Coast, and tunnel type corridors are primarily only seen in California and on the West Coast. But they have been added to the code, and I will explain them a little bit later in less detail than some of the other corridors. For fire damper actuation, there's basically two classifications the code has. Basically, all fire dampers that are used in smoke control systems, and then fire dampers that are used everywhere else in the building, not in smoke control systems. So basically, for all your typical dampers that have been in the code for quite some time, they need to close within 50 degrees of normal duct operating temperature. So your fusible link then would typically be set to 165 degrees. Now, most traditional fire dampers do use fusible links, and these links are basically two pieces of metal held together with a eutectic solder. That will soften and let the links separate when you get to a certain temperature rating. Unfortunately, these are not as accurate as, say, a bimetallic strip or thermal disc used in thermostats typically, or in the actuation of fire smoke dampers. Because of that, they tend to soften as you get close to the operating temperature. And if you can imagine, Pottorff is a Texas manufacturer. In the middle of summer, in the middle of a shipping container, the temperatures can exceed 150 degrees, which is very close to the 165 degree set point of the fusible links, which would cause the links to soften somewhat under the spring load of these fire dampers. And you can imagine that would also happen if you were close, if you had some sort of heat load in the ductwork, say if you're close to a heat exchanger or some type of electric heating element. That's why for those types of situations, we say specify 212 degree links, because your normal operating duct temperature is going to be much higher, and you could get some nuisance trips. As I mentioned, with that 150 degree container temperature, we have had, unfortunately, some shipments get to a job site after they've been shrink wrapped in the vibration of transport, that the fusible links have separated under transport, and they had to have been reset at the job site. Now, for all of the fire dampers that are in a smoke control system, there is an allowance for a minimum set temperature of 160 degrees and a maximum temperature of 300 or 250 degrees, depending on what that smoke control system is set for. Now, these are the smoke control systems we talked about in 909, and basically they're using the building HVAC system to pressurize certain areas. So if it's a non-affected area, say if you've got a 4-story building and there's a fire on the 2nd story, the 1st, 3rd, and 4th stories would be pressurized to keep smoke from getting in by keeping the supply open and shutting off the return, while, say, the fire affected area on the 2nd floor would have the return shut off and the exhaust open. The supply shut off and the exhaust open, to allow for some smoke evacuation out of the building. Now, of course, it makes sense that you don't want a fire damper closing as you're exhausting that hot smoke. So you're allowed to set the fire dampers to either 250 or 350, depending on the application of the smoke control system and the rating that it's set to. Code originally had a requirement that all dampers needed to close within a certain point of heat exposure, and that required a dual temperature resettable link that could be manually overridden because by a smoke control system at a control panel. This is no longer a portion of the code, but is still very common, and we as a damper manufacturer like to urge engineers to specify a single temperature link, because that's all that required for the damper at the highest level that's needed, so 250 or 350 depending on your system. The reason for this is there's no need for the override. The damper will stay open for as long as it needs, as long as it's been certified to close. It lowers the cost, so there's less wiring and less controls that are needed, and improves safety by adding that layer of keeping that damper open as long as possible while making sure the damper will close and protect the rated barrier that it's installed in. Pretty much we ask engineers as we go through this presentation if they do the dual temperature link, but we always urge people not to, because it certainly adds cost to the end user, the building owner, and whoever's buying these dampers. And we'd like to be able to reduce the cost as much as possible for everyone around, to make sure that while making sure the proper dampers are specified and installed. For smoke damper actuation, of course, as fire damper manufacturers, we'd love to sell you smoke dampers, but we typically recommend that you use the most cost-effective, the least cost option out there. One of the problems with fire damper manufacturers supplying smoke detectors, especially smoke detectors that are mounted in a damper, is they're not going to be addressable. There are a lot of smoke detectors out there, and most of them are not addressable for the fire alarm system or the building control system. Typically, the ones that are addressable are supplied by the alarm contractors, and they're very specific because they have to tie into the smoke control system and the overall control panel. Because of that, if you order smoke detectors that are mounted by us, we have to tie it into the damper to make sure that damper shuts down. And it will shut the damper down without a signal back to these systems. The damper, if used in a smoke type system will have damper operation indication, so you will know if the damper is open or closed, but you won't have an addressable smoke detector that will tell you where smoke is detected in the building. Because of that, and because smoke detectors can be installed within 5 feet of an unducted damper or 5 feet of a smoke barrier in a damper, or a damper installed in a smoke barrier, we typically recommend, if you do buy smoke detectors, buy them as loose for field mounting. Typically, when you get to a job site, there are a lot of trades vying for the same spot within limited space in these buildings, and because of that and the flexibility of being able to install that smoke detector within 5 feet of the damper, we do recommend field install, because then you can wire it back into your damper or your smoke control system and still have the flexibility to not compete with trades. As you can imagine, a fire damper can only have a sleeve so long, and because of that, there's only so much room we can put we can mount that smoke detector and all of the other boxes and electrical connections needed to make sure that damper will operate correctly. Because of that, a lot of times if we mount smoke detectors from the factory, you'll have actuators, boxes, and a smoke detector potentially on 2 or 3 sides of the damper. And because a lot of times these dampers are installed tight to a wall or a ceiling, there isn't a whole lot of flexibility once you have protrusions on either side of the damper. Because of that, we typically recommend shipping smoke detectors loose for field install. Now, of course, if you've already got smoke detectors because you are by a corridor, you can use that smoke detection system to operate and close the damper as well. So you may not need an additional smoke detector from a damper manufacturer. Now, for tenant improvement, a lot of times it's worth having that smoke detector with the damper shipped loose, because a lot of times it's not clear as to what is existing in the building, and you may a lot of times for these tenant improvement type renovations, what you'll find is a fire barrier has now become a fire smoke barrier with that added requirement of leakage protection. And that because of that, you want your damper to close in the presence of smoke, so you may need to have that smoke detector mounted. This is probably one of the most valuable slides, but we will spend the least amount of time on, because this is basically an overview by assembly type. It's meant to be a quick reference guide, and we go through all of the different assembly types in this presentation. One thing to note is the column on the far left side states the IBC section that we're talking about, and then the penetration in the assembly type in the next column to the right, with the portion of the code that dictates that assembly in parentheses. We've got some functions and some typical ratings, and typically we use this as an overview and a cheat sheet for the rest of the presentation. Getting into the bulk of the presentation, we will get into the most restrictive barriers, and we'll go to the least restrictive when we get towards the end of the presentation. Now, firewalls are typically one of the most restrictive, and commonly they're 3-hour rated. Now, it's a continuous wall from foundation through the roof, and it makes sure it won't collapse if the structure on either side of this barrier collapses. So imagine a firewall separating a building between a left and a right side. If there's a fire on that left side, that firewall will stay throughout the fire and make sure there's no penetration and no fire going through that barrier, even if that entire right side of the building collapses. Because of that, the minimum recommendation and the minimum requirement is a fire damper. There's no exception to penetrations through a firewall. As we get to less restrictive barriers, we get to fire barriers that will commonly be 2-hour rated or less. And their occupancies, they're used to make occupancy separations, protect incidental use areas, and most commonly shaft enclosures and exit enclosures and passageways. Now, horizontal exits may pass through fire barriers, and we'll talk a little bit about that later in the presentation, as they are commonly misunderstood. But for fire barriers, this is where you first start getting into exceptions for needing fire dampers. And basically the first few exceptions you will see throughout Section 717. So the first exception, ASTM E119, is basically the way you test a fire-rated barrier. So if you test a fire-rated barrier with a penetration without a fire damper, and it makes sure to stop the fire from spreading through that penetration without the fire damper, there's a heat load that they look at and flame spread. You can pass that barrier without a penetration, but it really doesn't exist. The reason that exists, it allows for innovation in the industry. It allows for people to test new and innovative products to protect barriers, and that's basically how innovation is allowed. The next exception is when fire dampers will interfere with 909 smoke control systems. Now, 909 smoke control systems are two main types. They're either going to be active or passive, and the active ones are mechanical 909 smoke control systems. So they're using the fans to exhaust smoke out of the building or pressurize non-affected areas and create a little bit of a vacuum in affected areas. There are also passive 909 smoke control systems that basically shut down the building. They shut down the air handlers and close all the dampers as more of a containment. And of course, if that's the case, there's no way a fire damper is going to impede with that because there's no air flowing through the system. So if a fire damper shuts and stops air from flowing through ductwork, it really can't interfere with a passive type containment smoke control system. Now, this is a valid trade-off for a 909 smoke control system, but typically what we see for fire barriers in a lot of cases is there will be a smoke requirement as well. And any smoke damper that's required for a 909 smoke control system, it needs to be tied into that system, and there needs to be positive identification if that damper is open or closed. Now, because of that, and because you've now got the added cost of an actuator supplying electricity and smoke detection needed, as well as indication for this damper, for a minimal cost, you can change that to a fire smoke damper. And the reason we recommend that is these are 2-hour rated or less barriers that are critical to isolating fires and keeping exit enclosures and shaft enclosures intact for the entirety of the emergency to allow all the occupants to exit the building or shelter in place and say a horizontal exit while firefighters and first responders are attending to the emergency and making sure everyone makes it through the emergency safely. Because of that, we recommend the fire smoke damper requirement for two reasons. One we'll get into is the third exception, where you've got a non-H rated occupancy that's fully sprinklered and has fully ducted supply and return systems. So there's no flex duct used, minimum of 26 gauge duct going through this fire barrier. And there's sprinklers. Now the problem with that and the added protection of a fire damper is there could be a duct breach. So imagine there's a fire and there's things degrading above that could potentially fall and hit and either puncture or rip this duct completely out of the wall. All fire dampers are required to go through a duct drop test. So this duct drop test basically has a fire damper installed in some type of wall. Typically the minimum would be a wood truss type wall, and then there's a length of duct connected to it. We'll use a typical breakaway type connection, your ward duct made, or typical S and drive slip connections. Take that all into account when we actually impact that duct. So the damper's installed in the wall with retaining angles, and a 55-gallon drum with about 400 pounds of sand is dropped on this ductwork. And that ductwork either has to break away successfully or remain intact without ripping the damper out of the wall, protecting that opening. This third exception does not do that. And a smoke damper is not required to have that type of installation. That's typically why we recommend fire smoke dampers for these applications, as you then have a proven breakaway connection that'll withstand falling debris and make sure your penetrations are protected in the event of a fire. Moving on to horizontal exits, I talked a little bit about basically shelter in place, or a means of being able to stay sheltered in a protected area because you can't exit the building for whatever reason. And basically, a horizontal exit is not an exit out of the building, but a passage through or around a fire barrier, whether it's a firewall or a fire barrier, that allows someone to get to an area of refuge because they can't exit a building. Typically, what you'll see for a horizontal exit, it may also be an exterior exit, but say for a hotel, there may be a certain stairwell that is an area of refuge for handicapped individuals. You'll notice this a lot of times in the placards that are in hotels that show exit areas, and there'll be a little red handicap symbol in a very specific stairwell. This stairwell was then designated as a horizontal exit, and because of that, there can't be any fire or smoke that gets into this exit because it is critical for someone who can't get out of a building to be able to have an area of refuge while first responders can get in and either help them get out of the building or fight the fire, extinguish the fire, evacuate the smoke, and allow them then the time needed to get out of the emergency. Because of that, the minimum and the recommended requirements are a fire smoke damper without exception. Now, of course, there are different exceptions based on the assembly type. So if it's a firewall or a fire barrier, you can use the exceptions of those different assembly types. But we definitely recommend a fire smoke damper because at the minimum, it's going to add a little bit of additional cost, but you'll need that smoke damper no matter what. And you'll get the additional protection of the fire damper, making sure there's no degradation of this barrier that can let smoke around the opening as opposed to through the ductwork. The next most critical type of assembly that we'll talk about are shaft enclosures. And basically, shafts are the way to move air up and down a building across multiple stories. Because of that, there is a very high risk for smoke transfer throughout the building if shafts are not protected with any type of smoke control or fire smoke control. In order to fully operate a building, basically to keep the occupants safe in these emergencies and reduce the loss of life, there are a lot of the minimum requirements are going to be a fire smoke damper. So you need fire and smoke protection. Now this is when we first start getting into the different type of exceptions based on fire damper, smoke damper, and construction and use. So, of course, the ASTM E119 exceptions are there for fire dampers, but we get into somewhat of a legacy exception where you've got a 22-inch subduct and continuous upward airflow to the outside. This is basically kind of a legacy exception. It's been in the code for quite some time, but there's no testing or any work that's been done to justify this as a valid trade-off for protecting exposure from fire or allowing fire to get into that shaft and spread through the building. Now, while it is likely that there isn't going to be massive fire going up and around this 22-inch subduct, if you want to use that subduct to remove the smoke damper requirement, you are required to have an exhaust fan that has continuous standby power, and you've got sprinklers throughout the building, and you're using it as, say, a toilet or bath exhaust. Of course, this is an exhaust out at that point, but the problem is the code is silent on requiring a high temperature fan. So you could have a failure of the fan that stops exhausting that smoke out of the building, and then potentially smoke can linger in this exhaust duct. So basically, as long as there's standby power, standby generators, and a high temperature smoke exhaust fan, we think it's a valid trade-off. Unfortunately, that may add additional cost because of that, and we think maybe a fire smoke damper may be a less costly option. Now, there are some exceptions allowed when you have a fire damper that'll interfere with a 909 smoke control system, or a smoke damper that will interfere with a 909 smoke control system. But typically, as I stated earlier, smoke dampers are going to be integrated in the smoke control system, so that's not really, even though it's an allowed trade-off, we don't think it's likely to happen. One thing that we do think is a valid trade-off is removing a fire damper exception, say in a parking garage shaft that's separated from a building by greater than or equal to 2-hour rated construction. We think that's a valid trade-off for above ground parking structures, as you've got the required protection with that barrier. The problem is when you get into subterranean parking structures, which get risky. Once you get into subterranean parking structures, you may have occupants that have to get past a fire to exit that parking structure. And because of that, and the high fuel load that goes along with a typical parking structure, we think it's incredibly risky to eliminate the fire damper, or more importantly, the fire smoke damper from that assembly. Smoke can then spread through the parking structure and make it incredibly difficult for occupants to get out safely. And because of that, we recommend for all subterranean parking garages that you leave the fire smoke damper protection in any shaft penetrations. One valid trade-off we always recommend is for kitchen enclosed dryer exhaust systems. Now, the Universal Mechanical or the Unified Mechanical Code does not allow for dampers in these systems, but the International Building Code allows the trade-off to remove the fire and smoke dampers in shafts when you're used for kitchen and closed dryer exhaust, and that is incredibly valid. Any damper or anything in that ductwork will collect grease or lint and create a fuel load that could then ignite in that shaft, and because of that, you really don't want to have any fire damper or fire smoke damper in these types of exhaust systems. Unfortunately, we do get questions about it where some local inspectors do require it because they are penetrating a shaft enclosure or a rated ceiling, but there's really, it's really not good. It's really not allowed, and basically we urge you to either get in contact with us so we can help you out of that situation, or to get them out of the specs altogether. Fire partitions are going to be the next restrictive type of assembly we talk about, and basically these are walls separating dwelling units or tenant spaces in covered malls, and most typically they're corridor walls or elevator or lobby separations. They're commonly 1 hour rated, but they and because they're fire partition, that's about the lowest fire rating you can get. Some valid exceptions we feel for penetrations in fire partitions is when they're mall tenant partitions that aren't required to extend to completely from the floor to the ceiling above or the roof above. Basically, they're not deck to deck, and that's valid because the fire is just going to spread above that area that's not protected by the fire partition. Now, you can also install a duct that's less than 100 square, or less than or equal to 100 square inches. Of course, 26 gauge duct, so it's fully metal duct, steel duct that has no flexible duct. That is in a subduct, that is a subduct in a sleeve that's 12 inches long through the penetration, held in place with 16 gauge angles and mineral wool between the annular space of the subduct and the opening. Now, the problem with that is that type of installation mimics a fire damper, and typically it'll be cheaper to install a fire damper and easier than to install this duct and subduct system. Of course, if you've got a fully sprinklered building and you use that 26 gauge fully ducted supply and return with a grill, you can eliminate the fire damper, but we think it's risky, as we talked about earlier, because it ignores the potential duct breach for falling debris in a fire. So typically the most valid trade-off for fire partitions are when that partition does not extend from deck to deck. Next, we'll get into corridors, and there's 3 types of corridors. I talked about tunnel-type corridors earlier. I won't spend a lot of time on those, but basically the 2 main types of corridors we're going to want to look at are corridors that are sidewall only, so there's no rated ceiling, or there's no penetration to the rated ceiling, or basically there's a drop ceiling, but it's not a rated ceiling. Typically, these are going to require a fire smoke damper. These are going to be the minimum and what we feel are the recommended requirements. We think the fire smoke dampers are recommended because corridors are essential for people to get out of the building. They're designed to allow a path of egress. They're commonly 1 hour rated, and they're allowing people to get out of a building in an emergency. because of that, we want to restrict the amount of fire and smoke that gets in as much as possible to allow people to get out with the most amount of time before the building starts to degrade in this emergency. Now, there are some exceptions, fire damper and smoke damper exceptions. Basically, you've got a fully sprinklered building and the duct is protected with fire stop caulk per section 717. You can remove the fire damper requirement, but we feel this is risky. And the main reason we feel this is risky is because there's no limit to that fire stop caulk, and you don't have that duct breakaway type connection that'll make sure the penetration is protected if there is falling debris in a fire. Of course, there is a smoke damper exception if you've got a 909 smoke control system and the smoke damper is not necessary for the operation of that smoke control system. So the wording's a little bit different as they realize that it's rare that a smoke damper will impede the operation of a 909 smoke control system because basically they're going to be tied back to the control of that smoke control system. And they're going to be opened or closed as that system dictates. So we think it's risky to remove that smoke damper requirement as I said earlier, corridors are essential for people getting out of a building in an emergency situation. Now, if you've got 26 gauge duct that runs above a corridor that doesn't serve the corridor, there are no openings to the corridor, you don't need a smoke damper or fire as part of the protection. And while it on the surface seems like a reasonable trade-off, we do think it's also risky because of that duct breach type of occurrence that could puncture that duct and allow smoke to get into a corridor that wasn't intended to because there's no penetration, there's no protection of that penetration. So typically for corridors, we recommend the minimum fire smoke dampers. Now, a little nuance to corridors is when they have a rated ceiling and a penetration in that rated ceiling. So if you've got a rated ceiling, and you're using the duct above to penetrate the ceiling membrane, you need a ceiling radiation damper. As you can see, there's either two types. It's either when you penetrate the ceiling only or when you penetrate the sidewall and the rated ceiling. Now, figure 4 is going to be the most common. As figure 3, there are very few rated ceiling assemblies that can be used for a horizontal ceiling radiation combination smoke damper. The reason for that is the ceiling radiation damper and combination smoke damper is basically a FSD type assembly, and FSDs need to be dynamic and they need to be installed horizontally to work in this application. There are very few instances in rated ceilings where you can install a damper like this, and basically it's limited to drop-in T-bar type ceilings where we'll talk about the different types of ceilings that are rated to UL555C. So remember that UL555C rating because it will come up again. Because that's become less common in the industry, you'll see figure 4 used quite a bit. When you've got a rated floor ceiling assembly that's wood stud or wood joist type construction, basically any combustible type of assembly is going to need to have a ceiling radiation damper that is specifically stated to be allowed in that assembly. And we'll talk about the different types of ceiling radiation dampers, but typically what we recommend is that figure 4 type of orientation where you've got a ceiling radiation damper protecting the ceiling membrane and you've got a fire smoke damper that's protecting the sidewall of that rated corridor. You can use the same types of exceptions that we talked about earlier, so I won't go through that again. Really what is more critical is allowing a horizontal rated fire smoke damper. So a specific, say, corridor damper, that's been approved to be horizontally installed in a tunnel type corridor. Basically, it's a special type of application where you've got the damper, the lid of the corridor is non-load bearing and it's of the same construction as the sidewalls of the corridor. We've got the industry has a corridor type damper that's been tested to be installed in that non-load bearing type of assembly. Now, smoke barriers are commonly 1 hour rated, but can be 0 hour rated as they're not a fire barrier. And basically, they bisect floors of underground buildings, but more commonly bisect patient floors of hospitals or other areas of refuge. Now, there was a change to the code in the 2015 code cycle where the fire protection group for hospitals lobbied to remove smoke dampers and smoke barriers in Group I2 buildings that are Condition 2 that have fully ducted systems that are sprinklered with either regular or fast response sprinklers. And basically their argument was they've dealt with a lot of maintenance issues with dampers. Unfortunately, a lot of their maintenance issues really stemmed from fire dampers, not smoke dampers, and dealt with smoke dampers that were installed quite some time ago that were allowed to be shipped without actuators from the factory. Most of their rationale for removing the smoke damper requirement were the dampers were installed incorrectly and never fully opened or closed. And that was basically because smoke dampers can be installed previously without actuators, with actuators installed after the fact when there was building power to operate these dampers by contractors. That's no longer allowed and hasn't been allowed for quite some time. All smoke dampers have to come from a factory after being tested for operation and are factory wired to fully open and close and are correctly mounted. So right now, there's really not that type of maintenance issue or nuisance issue that's associated with smoke dampers. But unfortunately, they were very successful while also relying on the training of their staff and the sprinkler systems to allow the removal of that smoke damper requirement. Because of that, and because it relies solely on the hospital staff to get the patients who typically can't get out themselves out of the building in time while the sprinklers are extinguishing the fire and creating a heavy smoke load, we recommend that all smoke barriers have a minimum of smoke damper requirements and typically fire smoke damper requirements to make sure that the damper will stay in place if there is a duct drop or a duct penetration type of occurrence, and give the most amount of time for the hospital staff to get everyone out safely. Now, of course, in other types of occupancies, where steel ducts are limited to a single smoke compartment, we think it is a reasonable trade-off that smoke dampers are removed because basically the supply and return openings are limited to the same compartment and smoke will not get out of that compartment to other areas of the building. Some smoke partitions that are more commonly 0 hour rated, but can be 1 hour rated, are used in corridor and care suite walls in Group I2 occupancies and certain elevator lobbies. And because these are smoke partitions, basically the only exception is to remove a smoke damper that will interfere with a 909 smoke control system, which we've said a few times is very unlikely because they're tied back into that smoke control system. Now, exterior walls are a little bit different. Exterior walls are bearing or non-load bearing walls that enclose a building, and there's going to be a calculation for the amount of protected versus non-protected penetrations of these exterior walls. This a lot has to do with lot lines and the proximity to lot lines, as well as the type of occupancy and the overall amount of protected versus non-protected penetrations. So basically, but it's like a fire, firewall. There are no exceptions if you've penetrated and you've reached the amount of the maximum amount of unprotected openings that you are allowed. Typically, because of that, because of your openings for glazing and access into the building, whether it's equipment access or personnel access, you'll find that HVAC ducts are going to be needed to be protected by fire dampers because you've exceeded the amount of unprotected openings. Through penetrations are a little different, and basically we're not talking about damper requirements here, but shaft requirements. And basically this is when shafts are needed versus when shafts are not needed. So basically anytime you're penetrating more than 2 stories, you're going to need a shaft enclosure, as we talked about earlier. Now, if you're not penetrating more than 2 stories, basically you're going from one story to another, and you can put a fire damper in that floor line, you can remove the shaft requirement. That's perfectly fine, but the only assemblies, or floor assemblies, that you can put a horizontal fire damper are going to be concrete or masonry. Especially the ones that are load bearing. You can have a fire damper or fire smoke damper horizontally installed in a non-load bearing penetration at the bottom or top of the shaft enclosure using a very specific assembly. That's an I-503 assembly. And it's a metal stud assembly that's used for the top and bottoms of the shafts to allow for a horizontal damper, as opposed to extending that shaft wall up to the ceiling above or the floor below, or building a fire-rated partition or room at that point that protects the top and bottom openings of a shaft. Now, of course, there are other reasonable trade-offs when you're penetrating 3 floors or less, and the duct is 26 gauge in the wall cavity, opens to only 1 dwelling unit and is less than 4 inches of diameter, and the annular space is protected, and you use a ceiling grill or radiation damper protecting the openings. You don't need that shaft, and that's basically for bathroom exhaust. That's going to be the most common use of that type of exception. Basically, other than that, you're going to need a shaft. And then we get into ceiling membrane penetrations. And I talked a little bit about this in corridors. And as a damper manufacturer, there are 3 basic types of ceiling assemblies that we deal with. Of course, there are hundreds of types of floor ceiling assemblies and roof ceiling assemblies in the UL Fire Resistance Directory. But as a damper manufacturer, we group them into 3 categories. And one category is a floor ceiling or roof ceiling assembly that has no allowed penetrations. Typically, this is going to be an engineered I-joist type application where you're not allowed to penetrate that type of assembly with ductwork because it really won't withstand the heat load and keep the fire rating of that assembly. Because of that, a drop ceiling is then required, and there's really no penetrations. Now, we do get calls about what type of assembly or what type of damper is needed per assembly. At that point, we always ask the question, well, what floor ceiling or roof ceiling assembly are you using to make sure that you can have penetrations? The first type that does allow penetrations are when you have a generic floor ceiling or roof ceiling assembly, and typically most of these are seen to be drop ceiling, where you're using fire-rated acoustical panels protecting corrugated steel above, and then either some type of fiberboard, ceramic board, or poured concrete. And typically those are going to be some of your older type of construction methods, and because of that, more generic dampers were used. It was before UL realized they needed specific models and specific protections for floor ceiling and roof ceiling assemblies. Basically, when you look at those types of assemblies, it's just going to specify ductwork and a very loose damper construction, and basically any damper that's certified to UL 555C can be used there. So when I was talking about the corridors earlier, any corridor that has a rated ceiling and it's a generic, say, duct or damper called out, where there's a 12 by 12 duct, and typically originally they were asbestos lined, but as we got away from using those types of materials, there'll be a flapper type damper or hinge door type damper called out for protecting that opening, and then you can use any UL 555C rated damper. When you get into very specific types of floor ceiling or roof ceiling assemblies, you get into these combustible wood joist or wood truss applications, or potentially some steel truss applications, where you're only allowed a specific model and manufacturer's product in there. Basically, because these are combustible applications, they will degrade and need more protection than a regular UL 555C damper. For those assemblies, there's going to be a manufacturer and a model specified, and those are the only assemblies, the only components that are allowed in assembly. Now, this doesn't extend to dampers alone. This extends to all the components of the floor ceiling or roof ceiling design. As you look through the fire resistance directory, you'll see hundreds of different types of assemblies, and some are very restrictive and very prescriptive, and some are more loosely operating. Basically, the main takeaway from that is knowing all of the insulation, gypsum, and damper allowances you're allowed, because we'd hate to have contractors or inspectors call up that have a certain floor ceiling or roof ceiling assembly with penetrations where they're not allowed. That's when knowing what's allowed in the ceiling membrane is required. Now, what you can do, if there is no ceiling radiation damper allowed, you can use then a shaft enclosure for this type of assembly. And typically we recommend that when you're going through a rated ceiling or floor ceiling, even though it's only going through one story, but that floor ceiling can't have a horizontal damper, at that point, a horizontal fire or fire smoke damper, at that point you need to use a shaft enclosure. And that's your way to get past that requirement. That pretty much brings us to the end of our presentation. If there are any specific questions, you can either put them in the chat and I can address them now, or you can email me. My email is jcarlin@pottorff.com. And the only question I have is this does have a continuing education credit attached to it, as long as you've supplied your first and last name when you signed up. We can get that credit sent out to you. Make sure you have your email address as well. If there aren't any other questions, I'll thank you for your time and stop now.